So today we're down in the Deep Creek region of the Southern Fleurieu Peninsula. We've got the opportunity to be in a soil pit here. We're in a 700 mil rainfall area. And with that, in this pit that we've got, we're really looking at more of a gradational soil type with a bit of structure in it. So we're looking at more of a dermisol soil type in this region. These soils characterised by their gradational nature. So we're going from transitioning from that loamy textured soil through to the lighter clays through this profile. From there we can start deep diving into the individual layers as to sort of how we ended up at that point of that soil classification. But really from a land management perspective, we want to understand what those layers may mean in relation to your overall production. And in this scenario, we're in a rotationally grazed pasture production scenario, but for you, it may be looking at a completely different production scenario on a similar soil type or within the similar region. So we want to be looking at these soils as a sort of a template for us to work through our management on, but also hopefully get a few skills that doesn't matter what the soil profile is that's presented in front of you. You've got a few takeaways that you can go and dig a hole in your own field and say, okay, this is where some of the opportunities or constraints may be lying for the production in my field. So when we are looking at a soil profile, critically what we want to understand is that soils are far more than just the 0 to 10 centimetres. We want to be understanding that soils are really a library of information and a huge store of water and nutrition, which then lead to the plant being able to extract that for plant growth. So to understand more than what's in that top 10 centimetres is the critical first step to understand what the opportunities are to take your soils and land management to the next level. So when we look at a soil profile, what we want to first understand is really what layers are in a soil. Soils are really a series of layers. Each of those layers can be similar soils or completely different soils. You'll have soils that are sand over clays and soils that are more gradational, like this site where we've got loams transitioning into lighter clays down through the profile. And that's a critical first step to understand. So once we have that soil texture, as it's called, so how much sand, silt and clay is in the soil, that gives us an understanding of what sort of the size of the bank account is, or the size of a battery. So a sandy soil is like a AA battery, so a smaller battery size, where a clay soil is like a truck battery, so huge amount more capacity to deliver nutrients, hold water and provide that support to a plant. Where the complexity then comes into it, when you're in the soil types like on the Fleurieu Peninsula, we've got a number of a varying age of soils through this region, from up to 500 million years old of some of these soil formations that have occurred through here, which adds another layer of complexity on how these soils will behave. So here in Deep Creek, we're on that southern end of the Fleurieu Peninsula, and a lot has happened through this region in general, and you'll get quite a patchwork of different soil types and get some really interesting features out of it. So don't be surprised if you do go looking around and don't fully see what we're seeing here. It's going to be a variation of a theme, or there might be something there to surprise you. Once we start looking through a soil profile, we've got a few key obvious things to highlight where we might draw the line on what the soil horizons are. So first one, really simple to do, is soil colour. So when we see the soil colour up here, we've got this first layer sort of in that 0 to 15 centimetres, is a bit more browner and earthier looking. So generally that's higher in organic matter or organic carbon in that layer, which is giving that soil that more earthy, browny grey colour. Then you can see there is this transition down to more of this yellowy orange into this next layer. You say, okay, there's something going on differently there. It's good. We can see this good amount of root system in this earthier layer on top. We're still getting root material coming down into this next layer here. And you can see when we're looking at just from the obvious things from the soil structure, which is how the soil is wanting to hold together, we're getting some of these sort of distinctive blocks or shapes that the soil is wanting to break down into. Through that, roots are still moving, so you're like, okay, there's something going on in this soil that is slightly different to this layer here. Then it starts transitioning again, and with that we see a slight change in soil colour. Again, we've still got some root material coming through, not as many roots as sitting above, and so that starts asking the question of what might be going on differently there. So with this layer sort of going in that sort of 15 to 30 centimetre zone, we've then go into this next layer, still seeing a bit of a colour change here. So sort of in this 15 to sort of 55 centimetre layer, we're getting some changes coming in through there. And then once down into this next layer, we'll see some different soil structure, soil colour and root activity. Again, we're getting a bit more mottling of colours. So mottling is when there's more than one colour in an area. So is it a red soil with some grey mottles, or is it a grey soil with some red mottles? So some other coloration in that soil is what we want to work out. What's really interesting at this sort of around that sort of 40 to 50 centimetre mark is there's some really interesting inclusions in here of been rounded pebbles or rocks in the profile. And as soon as you see rounded rocks in a soil, they've generally been rounded through landscape processes such as being carried by rivers or streams. So you're like, okay, here we are up the top of a hill in Deep Creek, and we've got river rubble sitting here. So that then leads to some of the questions around that soil formation, and obviously been through glacial periods. It's quite known for glacial till drop, and as well as soil disruption from upheaval and the orogeny of the formation of the landscape. So you are always going to see some really interesting things through this landscape. Quite often through this Deep Creek region, when you do hit gravel, it'll quite often be ironstone, which is a key feature of this sort of southern Fleurieu-Peninsula area. Then as we go down through the profile further, sort of getting into this sort of 50 to sort of 70 centimetre range, we've got an increase in clay content. We've got this coloration changing. The root concentration does decline, and that will start leading to ask more questions as to why that might be happening. And when we think about older soils, looking at the rainfall, sort of that 700 mil rainfall area, it starts leading to say, okay, what other processes might be holding this soil back or be influencing it? Which first of all would be like defaulting to checking the soil pH is a critical one, which we'll go into further. So we'll ask the question in some of these layers. As we then go down, we've got the more sort of obvious coloration change here, a bit more greys coming in. And when you see that grey coloration in there, you can do, if you think it might be, say, calcium carbonate, you might be able to do a test on it and put some dilute hydrochloric acid or vinegar on it to check, is it limestone or is it something else? In this scenario, it is a more highly weathered clay, and it's actually kaolinitic clay. So that is a one-to-one clay as opposed to a shrink swell clay as they're known. So not all clays are the same. So as a clay weathers, it goes from essentially a 3-layer stack. So it's called a 2-to-1 clay. So you've got, think of a sandwich with a slice of bread in the middle, is essentially how call it a younger clay would operate. Over time, those soils weather and then they become a 1-to-1 clay. Those 1-to-1 clays are traditionally less reactive, so they don't shrink and swell so much. So you might have a high clay content, but you won't get the big cracks in the soil coming through. And also, due to the weathering, they'll actually liberate a lot of aluminium and iron. So that is a key constraint to plant growth. So you've got to be really aware of that. If you've got highly weathered soils, evidence of kaolinitic clay in your soil, it's a fair chance you're going to have high aluminium and iron present, especially if your pH is low. And by low, I mean less than around that 5.5 pH is a critical measure there. And that will end up really sort of guiding you on what plant species or fertilizer regime or soil amelioration regime is going to be suitable for you. So really that sort of helps capture what's going on in that first metre of this profile. So underneath that, it goes into more of a clearly defined kaolinitic layer. But when we're looking at the production in this profile, we're going to focus mostly on that 0 to a metre. And with that, the most of the growth and production of the root development through this profile is really sort of coming down to that, probably around that 60, 70 centimetres sort of mark. So really want to be looking at, that's really the primary size of our bucket here. And that's what we've got to sort of work with. So one of the really simple tools you can be utilising in the field without having to send a soil sample off to a laboratory just before you start any of that is to really help you connect with what might be changing underneath the soil beyond just that soil colour change. One of those simple tools is to do a field pH assessment. Now, a field pH kit you can access from any of your local hardware stores, and it comes with a little liquid solution, a powder, to readily be able to just visually assess your soil pH down through the profile. So what I've done here is I've grabbed a little soil ped or aggregate or clump of soil out of each of these layers that I've identified through the profile. As you can see, we've got a nice colour change that we can visually see here as we've taken it out of the soil profile. And then I've used the liquid indicator and the barium sulfate indicator powder to highlight the pH changes. So when we do this, is all we're trying to do is colour match what's on the provided colour wheel with what the pH of the soil is. So in the topsoil, we're looking at around, when we match this, around that 6.5 pH. And what I did here was do a 0 to 5 and 5 to 10, and I do recommend that in the more acidic soil types, especially because we can get these little hot spots of where the acidity can be a little bit stronger. Down underneath that, we've then got this this third sample we've taken out. That's probably sitting around that 5 pH, 5.5 pH mark. And then when we start going down into this third layer down in here, we actually see that acidity increase, or the number get lower, so we become more acidic. So that's sitting around a 5 pH mark. So that's in this middle zone. And if you remember, that's where some of the root activity started to decline. So that helps us triangulate where we may actually collect some samples to be able to send off to the laboratory, maybe get a topsoil sample as well as a subsoil sample, to be able to start making sense of what might be influencing the plant growth and what might be a constraint underneath the soil. Underneath this layer, it then actually is becoming slightly more neutral. So looking at that 6.5 down through this bottom 70 centimeters to a meter, and then below that it goes back to being more acidic. So as we can see, like soil pH, just because you've had a test done in your 0 to 10 centimeters doesn't mean that that is representative of your whole profile. As the plants are growing down through that profile, they're having to experience these changes. When you are doing a soil test, and you will get some numbers back from a laboratory, it'll show pH reported as pH in water and also pH in calcium chloride, or CaCl it might be reported as. When we're dealing with acidic soils, we want to be looking at that number as the pH in calcium chloride. These field tests are actually more of a representation of the pH in water. So whenever we're looking at these numbers, you'll find that the pH in calcium chloride is around half a unit to 1 whole unit lower than the pH in water. So always take that or keep that in the back of your mind, that when we are measuring these, when it comes back from the laboratory, it's a fair chance they'll come back a little bit lower. So a soil that was sitting at 6.5 might actually test up at around 6 or 5.5. So just be aware of that when you're doing these field tests. If you do come across something that is a little bit challenging, doesn't necessarily fit exactly what you thought you might see in your soil profile, do get in touch with your local landscape board, and they'll be able to provide you the support to understand your soil profile in more detail.